All right, so now we have the action potential on the muscle cell. Neuron's done its thing, and now we've got the muscle cell, and we need to get the muscle cell to contract. So this gold looking area right here with the red arrows in it, that is the action potential. So that's this right here is the sarcolemma. All right, so the action potential is being propagated down the whole sarcolemma. And as it's being propagated down there, remember the T tubules are just invaginations of that sarcolemma. It's the same stuff. And so of course the action potential is going to go into the T tubules as well. So when it does that, the action potential goes into the T tubules. Just put that there. This is a T tubule. And you can see these little proteins on here. They're not gated channels, but they're just like little proteins. And when they come into contact with this action potential, the action potential flies by there, they change their shape. They change their shape, and they're kind of like revolving doors. They open up. Okay, so these proteins on the T tubules that link the T tubule with the terminal cisternae. Because remember, this thickened part is the terminal cisternae of the sarcoplasmic reticulum. And what's in the sarcoplasmic reticulum? Well, calcium. So these proteins are going to change shape and open. So these are going to, let me go back over up here. So they're going to change shape and open up. So now calcium leaves the SR, the sarcoplasmic reticulum, and enters the intracellular space, enters the sarcoplasm. All right, so the cytoplasm of the muscle cell. So it is, you can see the calcium in there, that's the stuff, and it flows out. See, it's flowing out right here. Okay, so it's going to flood the cytoplasm or the sarcoplasm. Okay, and look where it's headed. It's headed right over here to where the sarcomeres are, to where the troponin is, and that's where they're going to link. And that is, so the calcium, let's put that, so the calcium will go to the myofibrils and bind to troponin. And why does it bind to troponin? Because troponin is the only way to move tropomyosin out of the way of binding sites for myosin. Okay? So that is EC coupling, is what we've just done. So we had the excitation that came from the neuron. That was the action potential. It came down the neuron, was gotten across the, the cleft utilizing acetylcholine, and then It started again on the muscle cell. Is being propagated down the muscle cell, goes into T-tubules, opens the doors to the terminal cisternae, letting calcium out. Calcium goes to bind troponin. Boom, now we have contraction. Okay, so that's that coupling right there as that action potential goes into the T-tubules and lets the calcium out of the SR. So let's see what happens next.